Okay, at this point, what I'm going to do is I'm going to introduce our speaker, our professor for the afternoon. I know her. I've been knowing her for several years. She is an adjunct professor at Morgan State University, teaches physics. Her name is Majida Murdoch. Her journey into physics started with her first love, astronomy. As a young girl, she loved looking through the telescope and wanted to travel to space, which eventually led her to pursue physics. Majida graduated from Morgan State University with a bachelor's degree in physics and in mathematics. She earned a master's degree in physics from the University of North Dakota. Currently, Majida is a lecturer in the physics department at Morgan State University, a math teacher at Randallstown High School, and a STEM advocate. Majida serves as a STEM advisor for some local private schools and after-school programs in the Baltimore area, and collaborates with quantum information science and technology education programs, bringing opportunities to engage youth or teachers in physics concepts is something she enjoys doing. Last summer, Majida created a successful pilot program using quantum literacy with a small group of students. This summer, she worked as one of the facilitators for quantumforall.org to train 8 physics teachers and over 30 high schoolers in STEM and quantum applications at Morgan State University. Majida's collaboration with National Q12 Education Partnership and with Qubit by Qubit allows her to make a difference by bringing QSI opportunities. I'd like for you to give Professor Majida Murdoch a round of applause and welcome. I'm sure you're going to be thrilled at what she's going to do with you today. Majida.
Thank you very much. Thank you. Good afternoon. I have the task of talking to you after you just finished eating. So therefore, I have to make sure that we keep us active and thinking and alive. And I'm a person who likes interactive conversation. So I want you to feel free to ask me questions as much as possible. What I'm going to do is there was a question of what is quantum? And we're working with the groups, different groups. I don't know if you knew, but April the 14th was what we call Quantum Day. And this was worldwide. So prior to that, the rest of the world was doing it. And then the United States is like, hey, we now have the money, we're putting some effort in, we're gonna also to do this. This is only about a 3-minute video, okay? Just 3 minutes, 3 minutes and some seconds. So you're gonna see why I like it so much. All right, so we're gonna play it. If you don't mind, just go ahead.
Think small. Even tinier.
Can you hear it?
Oh, and also older.
I don't know.
Keep going. Yep, right there. That's quantum.
Pretty tiny. Might seem insignificant. But quantum, the science of the super small and the super cold, has transformed our lives. It gave us lasers.
I'm gonna stop it and see if we can get it loud.
Okay, so you do that. I'm gonna go to the next part and come back to it, okay?
Sure.
All right, so this is a really cool video. I love it. My area, how I got into quantum is because I started in nanotechnology. My background and at at University of North Dakota under William Schwab. He was a theorist. He's looking at this, what we call graphene, okay? It was so cool because the whole idea, and this is, I want you guys to understand this. This guy got a Nobel Prize, right? I mean, I think it's like $100,000, the prize, because he took Scotch tape and a pencil and rubbed the pencil on some paper and took Scotch tape and removed layer by layer. And what happened, he got it so that it was just one atomic layer. You follow me? Because he was able to do that, we began to study this material more. And we find out that this graphene of graphite, graphene, is very, very strong. It has some very unique properties. Now, graphene is nothing but carbon, right? And carbon, we know that when you do your barbecue, because here's the summer, grilling outside, we use carbon, right? We like diamonds, bling, bling. That's carbon, right? At a higher intensity. So carbon is nothing that is not new, but we now have technology that we can look all the way down to the bottom. When I was a little kid, I was told that we were never able to see atoms. Became a big kid, and I'm like, you mean I can see an atom? Well, it doesn't mean that you can actually see the atom, but can I use your paper here? If I take your paper, and you just imagine this is somebody laying in bed with a cover on them, and they're under the cover, do you not know where they are? That is what I pretty much is talking about, seeing an atom. You can see it up there, right? You don't see me, but you see me. We couldn't do that before. We can do it now. Does that make sense? So now we can say we can see atoms. We can manipulate atoms. So I always like to tell my students, you ever think about, we just had a good lunch, you want to have a good piece of cake? Can you tell the difference between store-bought cake and homemade grandma love you very much cake?
Yes. Oh, yeah.
You can tell the difference between the two?
Yes.
When you eat grandma's cake, can you actually taste the butter? Can you taste how she filtered out the flour? You follow me? Each ingredient was something that was very unique, yes?
Yes.
All right, doesn't taste the same thing as a store bought. I mean, it may be a really good store, but you can tell the difference between the two. So if I take this grandma's cake and each of the items, let's say the butter, and not just get the best butter, but let's say that you have the science to get underneath and manipulate the atoms so they line up to get the best of the butters. Does that make sense? That you're able to line up the flours to get the best of the flour. And then you make your cake. You know you're gonna have a cake that's what? Out of this world. Does that make sense to you?
Yeah.
That was what we were with nano. It's taking things at atomic level. But there was a problem here. When we take things too small, we as scientists really don't understand it. You and general public thinks, oh God, we must be very smart. But the reality is like you're in kindergarten and we may be in 5th grade. And if you think about it, you're in kindergarten, doesn't that big brother or sister yours who's in 5th grade seem so smart? Because he know a lot more and understand a lot more. But us as a scientist studying nature, there's more that I need to study. We can see things like this, but when you take it so small, how are we coming along? You cannot see it that well. So at this point here, let's talk about seeing something that's very small and understanding, because it took me from going to understanding electrons and their energy density of this thing called graphene, because my point here is one of my favorite topics is water. Yes, water. I believe water is going to control the world, because you won't believe this, guys, but 20 years ago, to say you drink water out of a bottle, you would be bougie. Okay? Nowadays, you wouldn't want to drink anything but sometimes out of the bottle. And you might make sure where you're getting it from in that bottle is of a good quality, right? So what I wanted to do is I figured out what we found out with this graphene is that I can take the worst water, so located anywhere in this earth, and pour a cup into this filter, and it will become 99.9% clean. Then I would drink it right away. This graphene layer, wafer, cleans all minerals, bacteria, things of that nature. But this is the point. If I take a helium atom, which is much bigger than the water molecule, it will not let it go through. I mean, excuse me, helium is much smaller than the water molecule, so it will not let it go through. We don't understand the quantum, the rules. When I think quantum, I think of the rules that make things work. Just like if I take your pen and I move it like this, I can get a formula to figure out how far I can make it move. I can't do that in quantum so easily. You follow me? Our rules that we have is on simple things. I need you and your friends to start thinking about how we can make things, manipulate and do things the way we want so that we can get some really cool things. So here we go. And you
Small.
gotta
Even tinier.
better. 3
Oh,
minutes. is all
and
left.
also older. Keep going. Yep, right there. That's quantum.
Pretty tiny, might seem insignificant. But quantum, the science of the super small and the super cold, has transformed our lives. It gave us lasers for surgery, for trapping and cooling and investigating atoms, and cat toys.
Quantum technology gave us the atomic clock, which is the beating heart of GPS, allowing us to navigate all over the world, wherever we want to go, avoiding traffic jams, and finding our way home.
Also, it's the science behind MRI scans that let us see what we're made of.
That's just the beginning. Scientists and engineers use quantum every day to understand nature and build new technologies.
The idea of being a scientist was always kind of exciting to me.
When I was in high school, I had a fantastic teacher who showed me that chemistry is more than just mixing chemicals.
When I was a teenager, I wanted to be part of a scientific revolution. After years of searching for one, I stumbled upon quantum information science.
When I was growing up, I was always reading a book. I loved building universes in my head. Now I get to do that for a living as a quantum physicist.
Now as a physicist, I build quantum sensors.
Now, I write software that helps predict the quantum behavior of different molecules.
Now I develop software for quantum computers.
It's actually pretty exciting to imagine sending these sensors into space and that they could help us learn something new about the universe.
Everyone has their own reasons for getting into quantum.
I want to be a creator, not just a consumer.
I want to explore the unknown.
I want to inspire my students.
Anyone can be a part of quantum, and it's never too late or too early to get started.
I'm a part of quantum.
Yes.
I'm part of quantum too.
I too am quantum.
Let's quantum together.
Let's quantum together.
Feliz Día de la Quanta.
Happy World Quantum Day.
Happy World Quantum Day.
Happy World Quantum Day.
So me, Quantum Day is every day. It's almost like I tell my kids, Mother's Day is every day. You respect me every day. So therefore, the Quantum Day works the same way, all right? So now, we want to talk about exploring things, correct? So what I'm going to do, I'm going to use a very classical experiment with you first, just to get your minds moving, because your stomach is like, so we got to get the minds over here, all right? So what I did is I gave each one of you guys a little white and red envelope. Can you just look at that there? And what you have in front of you is you actually exploring things, because you don't know what it is, correct? So what's the first thing you're going to do? Talk to me. Say again?
Flip it over, look on the back.
Flip it over, look on the back, and what do you notice it says there?
Fortune-telling fish.
So it's something like a fortune-telling fish. So personally, I don't believe in fortune-telling, but you know what? Some people do, and this was a big thing in one of the years ago. All right, so now, what else are you gonna do? Now, come on. You're exploring, what are you gonna do? You're gonna read the instructions on the thing, okay? What else are you gonna do? You gonna find the rules? Okay, but notice in nature, there's no rules written for you, correct? So what are you gonna do? Open it up. Come on, folks.
You told us not to.
Oh, that was before when I started the show.
That's why you didn't bring it up.
You got me, you got me, you got me. All right.
You know, it says fortune teller, magic fish, miracle. I can't tell about a fortune, I don't have one to tell about.
Love that. All right, so go ahead, open it up here. What do you see? Come on, you know, I tell my students here, listen, you got 5 senses that God gave you. What are the five senses? Come on, talk to me, because let me understand something. Your brain is in like a cavity, totally enclosed, totally dark, can't hear anything, but you have five main functions of getting information to your head. Those five functions, those senses, what are they? Talk to me. Sight, hearing, touch, smell, taste. Okay, now please don't anyone taste this, okay? All right, you don't have to go through that sense, but what do you notice? Tell me about what's going on. Okay, work on the fish. Open it up, yeah. Put that fish on that palm of yours. All right, and notice here, you're gonna use your senses. Let's say you're being scientists here. And to me, being a scientist is being a child, because every child is curious. They wanna know how things work. Come on, brother.
Oh, no,
You must be awful opening your birthday gifts. All right. So what happened to it? Did you put it on your wrist?
I'm getting passionate.
What happened? I mean, put it on your wrist. What's going on? Now, I'm gonna tell you now, the fortune was how we used to make money off of people. I'm not here to make money off of you. I'm here to talk about the science of observation of something you don't understand. Is what we're looking for, being a child. Put it in your palm. What happens? It starts moving around. Does it matter if it's on your right hand or your left hand? No. All right, so now wait a minute, hold it. So what are the questions that you ask yourself here? How is it moving? Does it have an electrical battery to this? Is it something nuclear that's making it do things? What do you think? What are the questions you ask yourself?
Why is it moving differently for everybody else?
You start looking around and noticing people doing things differently here. Oh, okay, but you remember direction, that means that was me trying to get money from you. So I may not be really honest here.
Remember, I'm fortunate.
All right. So, okay, well, hold it, wait a minute, hold it. What I do tell my students here, you put it in your palm of your hand and notice what's going on. Put it in your other palm and see if that's the same. Because my question is, does the right hand do the same as the left hand? You're talking about things being transferred. You're sitting here like, huh, ain't working for me, huh? Oh, it is.
It's just moving slow.
Slow, okay. Now, somebody's your neighbor, if you don't mind sharing your fish with somebody, the person who is nearest you, switch fish.
Here you go. Take mine.
Switch fish.
Keeps falling out of my hand.
And see what happens here.
Okay.
All right. Now, we ain't even got to the quantum yet. We're just talking about being inquisitive as human beings.
I am still.
All right, so what are the questions? What are the things that you're asking yourself here? Okay, his palm is different than yours. That means the fish did something. So it's doing something different for everybody. So I gotta have a whole list of rules of what's going on. What's going on here?
Was passionate. The other one.
All right, my question. I'm throwing questions out. What kind of material is this fish? These are the next things you're asking yourself. You looked at the way it's moving. Someone asked, is this plastic?
Like, I'm seeing through it like it's plastic.
Notice what he said. I'm seeing through it. Like it's, so that means that it is thin enough that you can see through it, correct? All right. And what kind of material is this?
I guess it's some sort of a polymer material.
It's a polymer material. We got polymer. Notice what we have. We can call it plastic, depending on what level you want to go. You can say that it is like a cellophane. Cellophane. Thank you so much. There. You can look at that. Or you can say polymer. We can take this on a level. And believe me, I do this to my college students and break them down and say, what is it that you're trying to do? All right, so let me help you here.
We're sleeping fish.
Two emotions. Anybody have any little water with your water bottle by them, something? What would happen if you just put a little bit of water, just dip your hands and put what will happen here? Because my next question I will ask is, what would you think is moving? What is going on here? You have 5 senses, right? Besides tasting it, I don't want to only taste it. What else do you observe going on this? Because as scientists, this is what we do. When we get to talking about quantum, we use machinery to help us use those 5 senses. Woo! It just really curled up. Now, let me give you a clue here. This material is a certain type of polymer, and it is what we call hydrophobic. You know how you have phobic means you're afraid of something, right? So that means this is something that does not like water. So if your hands was very moist, okay, that's why I said to put some water on it. What it would do, it would move away from it, okay, your hand. So this hydrophobic is materials that we use in diapers for our kids to pull the moisture away. Where else do you use, you see those little pellets sometimes come in with your shoes? Ah, yes. Same philosophy here, okay? And what happened is that we learn now, even at the atomic level, which we said, very small level, of maneuvering up these atoms so that we can get the things that we want, all right? Now, that works very well, and that was just an intro to understand the smallness itself. What I want to do is move into my next field, and that was quantum. Now, as I said to you, my favorite, personally, my little story, I love the idea of water. I love water so much. I tell my students that it's not coffee or sodas or Coke that you need to drink. If they're saying that 80% of your brain is made of water, that's clean energy. You need to put clean energy into your body. Woo, H2O. Not soda, that's dirty water. That's dirty energy for your brain. Body is at least 75% water in order to make it function. And there's those who did studies to show that the more water that you put into your body, the more healthier you are. And some people feel is that some of the problems we have because we don't drink enough water. But then we find that as physicists, we really don't understand water. So this is the gift of life, if I could put it that way. What is a gift? You say thank you very much so, but you don't understand it. And this is the mechanics, the science of how this is going to work. So leaving there, I wanted to understand more about how water works, and that's how I tumbled into the quantum world. I wanted to understand the rules. What are some of the rules that can help me to help you? Because water has such a unique property. There's a reason why when you brush your teeth in the morning, you rinse your mouth with water, it has a polarized ability that it literally lifts off the germs and the dirt out of your mouth because of that ability. So you're like, water? Yes. I know Listerine says it does a great job, but water does a good job too. So now we get to this thing about at the small level, the smallness at the atomic level. And, oh, you really drenched it. That's okay. I love the energy to continue on. All right. Listen to me as you play, okay? All right. So what we want to do, we realize that we're talking about how to move information. Now, you know, prior you were saying that we had such a large influx in revolution, which was electronics, right? Think about this. 5 years ago, just 5 years ago, how many people had cell phones? Okay. Oh, you all had cell phones. Okay.
That's 5 years ago.
5 years ago. We can go back than that. Okay. I remember having the cell phone in the car that looked like a big suitcase. And that was what they call the phone, but we won't talk about that. So let's talk about 5 years ago, your cell phone that you had versus the phone that you have today. Would you want to go back to that phone?
5 years ago.
5 years ago? No.
Only if this one doesn't work and I gotta use the old one.
Let's say that it doesn't have what you have now. It's what it was 5 years ago versus what you have today. If you can work with me. Yeah. Coming from Baltimore, yes, I really did use my navigation. The GPS was my best friend, okay? When it says turn right, I say, yes, ma'am, I'll turn right, without any question. But the thing here is that we're using communication. and understanding how to use it is very important. You had mentioned about this thing of quantum, what it's about. Quantum is, as I said, it's using the electron, it's using the proton, it's using the fundamentals that we were taught. We were taught at one time the atom is made of what? Atom, electron, proton, and neutron, correct? Now, what if I tell you that is not the fundamental? I said the fundamental is the electron. As a physicist, what we do, if I can't slice it, dice it, make French fries out of it, I'll pay homage to it. We can't dice, slice electrons. Am I correct at this moment?
Yeah.
So therefore, it's the king of everything. But the proton, we can smack that baby. We can make that baby do all kinds. You smash it, and all kinds of things come out of it. And that becomes subatomic. Did I say something? All right. So these subatomic things makes up other things, which makes up the proton that we have. So that means there's a whole lot of understanding nature. I'm not going to use the word physics. I'm going to say understanding the laws of nature of how things work. And because we now have machines to do that, we're going to work today. What I like to do is I give each one of you guys a group of 2 things, some filters, right? I think I gave you 2 gray and 1 white. Yes? All right. One of the things that we're going to look at is light. L-I-G-H-T. Okay? Light is so unique. You may have seen the cartoon character of light going in one ray. It's not that. Light is like, you know how your person center light, it's all around, it's unpolarized, it boom out there, you follow me? Yeah, that's what you call unpolarized, it's all over the place. But if I hold a filter, just like you have polarized glasses here, what it does is that we gotta understand what light is. Light is an electromagnetic field, right? And I love to do this because it's before I get my dance here. There goes this way, and you got one going this way. So you have them both going the same way. Okay, let's see if you can do that. You got one going this way, and you want going perpendicular to that. So you got, yes, it's going this way. Yes, that's how we got it. I know it looked like you're doing a little dance here, but that's keep you awake while we finish, because you just finished your lunch. All right. So basically, I have a field moving this way and this way. And what they're doing is they're isolating. I can control that field. Can I use your fingers? Can you go like this for me? Sure. If I have something that is isolating, correct? That means that the one that's going in this direction will not what? Go through.
Stops.
It stops it, yes. You follow me? Yeah. All right, so if I have, I can't do it this way, I gotta figure out. But if I have it going this way and one going this way, no, this way. Ah, there you go. Yeah, that's what I want. All right, so here we go. This one won't go through, but this one will. You follow me? It would filter right through there, yes? So you can control, you can control light. Controlling light by using filters. Hint, hint, polarized glasses. Hint, hint, controlling other things. And light is a simple particle. So this is what I want you to do. Take 2 of the gray filters. I would like you to look at all different lights here. We got ceiling lights, we got, I don't know how outside lights will work. And because you have reflection, you should maybe get something from your table. Do you see any difference? You know, just everybody should have at least one, just to turn it around and see what's going on there. All right? Because that means you have a filter going either horizontal or vertical, an H filter or a V filter. I don't know which one you have. Because you know what? We don't know. We keep it. How are we coming along there? All right. All right. Now, wait a minute. Hold it. Now, this is the trick. If I have light coming in one filter, right? Remember, this thing is moving, oscillating, and you want to control it. So I have you coming in, and you're going to be the vertical, and you're the horizontal. Follow me? So I want to filter that only my vertical can come through. So that means you're going to be excluded. So I can control the components of my light. All right. Wow, this is pretty cool here. So I'd like you to do is use one filter and then take another filter, and I want you to oscillate it to see what happens here. Right.
What it is, it changes the color. It almost filters out some of the waves and then just give me maybe almost like an ultraviolet light coming through. When I twist it a certain way on that light, it turns it blue. I turn it this way, it turns it mostly yellow.
Okay, so we know light is a multi-color. It has, so you can pull out what you're looking for. Yeah.
What it is, it's cut out everything but the ultraviolet.
Yes. He was. Alright. So these are ultraviolet glasses that you look for. You know, they're a little bit more expensive because you can control. And you know those commercials where they say we got the new visor glasses that, you know, doesn't let any light go through, but yet you can see really great. They're playing with the lenses itself. So wait a minute, hold it. Let me understand, folks. I have your attention. 1 second. I have. Can I use your fingers again? Okay. All right. So we got one filter this way, correct? And we have light coming in and it's filtering what we want. And then I took another one, I had it this way, yes? And then what we did, we started twisting it. And when we twisted, what happened? It kind of disappeared. Now, what do you mean disappear? Because the thing that for me, as a scientist, I know what's going on. The concept, I got to make sure my kids get it. Because as we go to the next level, I need you to be with me here, okay? So when you have it like this, one more time, all right, okay? Sure, you got it. For the name of science, I appreciate it. All right, so we're here, twisted. Oh man, at this point here, notice they're 90 degrees, they're orthogonal. That means that you're literally blocking all the light. Ooh, I got an idea. Now you got two people. I want one person to have the two gray, and I want the third person to put the one in the middle and twist it and see what happens. Oh, but before you do that, wait a minute, hold it, let me understand. We understand that we're looking at decomposition here of light. So you have light coming in, you filter a particular H or a V point here, right? Now, before you do that, I got the math part of me is something you have to hear. You guys have seen this in your geometry. What? Yes, when you learn geometry and you learn about array, start with the point, go out, that's array. And then your teacher said, well, let's multiply that ray by a -7. And that means negative means it flips this way and it moves 7 units more, correct? So you know the mathematics behind it. You just have not connected the two together. Are you with me? Or what I could do is I can say, if I have a array, and we're gonna go one step more, algebra 2, and we're gonna call it a vector. Now we can call this point based on my X and Y coordinates, right? Because that coordinate pair is nothing but a vector notation. You follow me? You're doing a little quantum at the elementary level, but you're still doing it. So I need you to understand, I'm not showing you anything new, I'm just showing you how to connect the two together. All right, now, this is what I need. You have a filter, you have a filter. And we know that when you look at them, you should have 0, correct? Now, I need the partner, I need you to put a third one in between, and I need you to rotate it, see what happens. Because that's what all scientists do. We're trying to figure out, what if I can do this? You gotta put a third one in between.
You have one like that, right? You start rotating the first one. Where that one?
Still.
So can you see the two?
You have them?
Yeah.
Okay.
No, let's say here, these two, the outer ones have to stay the same.
Oh, okay.
It's the center one that you want to rotate.
Okay. All right.
All right.
Let's try. Yeah.
Make sure that you can't get no light between the orthogonal. Whoa, orthogonal, man, that's geometry words. Yes, 90 degrees to each other.
Oh,
Orthogonal vectors. Get to quantum and you get into chemistry and physics, we talk about orthogonal bases.
Do it this way.
Well, you already have yours twisted. You have to have one not twisted.
Oh,
All right,
not my
and
fault.
then we can try. Do you have to use the white one in the middle or?
Well, I want them to do the gray and then I want them to see what happens. So after you do the gray one and you take note of what goes on, use the white one. I like to play.
Okay, it's working.
You want to try the white one?
To hit my
When you
start button.
twist it, it blocks out the light of the building across the street. When I twist it back this way, I can see right through all three of them, to see the building.
Yeah.
Now, guess what? I want to use a little technology here. So I want you to take your phone, because everybody has a cell phone these days. I shouldn't say that, but I'm assuming we all have cell phones. And you have a flashlight on that phone. All right? You have a flashlight on that phone. So you're gonna turn the flashlight, because now what we're gonna do, we're not gonna use, any light. We're gonna use some direct light. And we're gonna put the filter in front of the phone. You follow me? See what happens? Then we're gonna put the second filter in front of the phone, play with it and see what happens. And then to top it off like candy on the icing of a cake, you're gonna put a third one in the middle and twist it and tell me. Now, normally what I do, it'd be like a lot bit more. I would have paper, have you taking notes, writing down your observation. But I think you got the idea here, is that what we're talking about is something they had talked about is detanglement and cohesiveness. And because you now understand the concept of this, I feel more confident in introducing these words to you. Because you know what? You touched it. You understand it. So when I had the two waves and you got to see all the way through, they was cohesive, is it not? All right. And when you have them so that they're not, that was more or less decomposition, yes? So now I can use these vocabulary words and expect you to be able to give me those words back, yes? All right. Here we have the quiz at the end of the class. Are we good? All right. To make it easy, I lay the phone down and make it easier so that with your hands, and you can take one and play with it and see what's happening here. No. While you're doing this, I need to ask you a question. Do you have, anybody have a bank card? You know, that they use a bank card, a cash card or something of that nature that you use? One of the things, we're doing here is that to use that card, you have to use a code, right? Tick, 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 and that bang, you got your money. And you don't want other people to get your code, correct? As my code, my money, my hard work, yes? Yes. Okay, now, these days in time, you have somebody somewhere who's sitting there like, how could I get his money? That is a big thing today. That's why we have so many scammers. Remember, I would say pre-pandemic era, the pandemic time, you had so many companies, somebody was broke in to take their history. Someone broke into this one and took their history, right? You're like, they better not take my money, right? But you know what they're thinking here? It's like, wait a minute. Just like you have a hand, light goes through. Once you put that other object there and you change, because you changed the experiment, correct? It wasn't just free light, it was here, and then you made it what? Vertical, yes? So anytime you do an experiment on light, light will tell you that she touched me. Follow me? So therefore, in the idea of this crypto secrecy here, getting lost in words here, is the idea is that I can do things, and if I know someone touched my code, it will let me know. And it will change it so that you can't have it anymore. Because once you touch me, I'm destroyed. Well, that's why they take your card and destroy it, because they want no one to have it. But unfortunately, by the time you pull your card out and get to the car, someone in Arizona, I'm going to use Arizona. Thank you. Just like that. Somewhere in Florida, okay, has already purchased a car, did this, did that, and everything, and your name with your card number. You follow? So the whole idea is, how can I keep my information secret or let me know when someone has touched my information. So this idea of coding for secrecy is big. Now, what if I tell you you've been doing this in your Algebra 2 class? Would you believe me? No, I don't remember my teacher said nothing like this, but they didn't have to. Let me give some. And get help me. A linear equation. Okay, I'm going to get math on you. So just hang in with me, okay? Math. Remember that equation, mx plus b? We all know what that looked like, right? Yeah. Then drill into your head. The linear equation, right? Y is equal to mx plus b. That's a line. Now, I have 3 objects. Now, I'm going to give 2 objects. Now, I'm going to ask a favor of you. Do not look inside, okay? Please. So I'm going to give one to you, madam. Right here, okay? And I'm going to give one to you, sir. Now, this is the thing here. You remember how you talk about relations? Meaning that a relation is for every X, there's a Y. Remember the teacher been telling you that stuff here? You're like, okay, there's something about that. That means for every incoming object, there's an outcome for it. If you do something, then you reap the benefit of what you did. Yes? That's math. So now what I'd like you to do, let me do it here. I want you, if you can, and I'll give you about a few minutes, so I got time, right? Little time. If I pull, this is very trivial. If I pull this string here, what happened? Let me do this one. If I pull this one, what happens? So this is my input, and my output means it went up, correct? Yeah. So if I do, hold it. If I do this one, it's like the diagonal one moves. But wait a minute, hold it. And if I did this, okay, let me do this one here. Something is going on. Can I give it to you? Sure. And you can pass it around? So I know I should have did more. So sorry. Okay. Next time I see you, I'll have a whole lot so you can make your own. But the point here is that for every
classrooms, my students can do this too, right?
Yeah. Oh, definitely. And it's very easy. I did it in my class. I'm writing it up too.
That's, yeah.
You like it? I got you there. All right.
You just explained, yeah, and additive and subtractive math right there. I mean, like, mind blowing right now.
So when you pull on this string, something happens. This is input, this is output. That's relation. Everybody has a relation. I don't know you, but even meeting you this time, we have created a small relation. Now, when I pulled on one string and you said, oh, but this went up, and then I pulled on this string and then this one went up, that means that we have an inverse of each other, okay? And because of this inverse relation that we have, woohoo, that means I can do some controlling here, because that means that one function is the inverse of another function. There's a key. And if I take that key and multiply by a prime number, remember prime numbers? As numbers that only 1 times itself will give you that value. If I multiply this key with a prime number, only you have the key to get to your bank account. The computers today, it takes a while to figure out your prime numbers. You're not supposed to look at the end.
Curious, right?
But the quantum point here, what it does, it allows you to not be able to understand that once that key has been touched, it lets you know. And therefore you understand this, that inverse is very important, that keeps your key to open up your account. Only you and the bank has access to that. No one else in no other country or another place sitting there figured it out yourself. And that is why so many countries, including the United States, has put a lot of money to figure out how, because we got quantum computer, it's very simplistic, but we want to take it to the next level. I hope you got some good minds here to take it to the next level so that we can keep our secrets and honestly break into some other people's secrets. Okay. Now, as not only is quantum good and keeping secrets, but it's also understanding the movement at a very small level. And that's what quantum sensing, did I say that correct? Quantum sensing come in, is that we, remember I said it was so small that you can't see it?
What do you see?
We don't understand all the physics behind it, but because of those 5 senses, we use machinery so that we can see it. So something very small using a microscope or electronic microscope so we can see something at the atomic level, or looking at the waves or the frequencies, we're able to understand more about this. So what I am, hello, my name is Professor Magina Murdoch. I'm here working with the Quantum Initiative groups, and I'm here to let you, hopefully, give you some information on what is quantum, how we can use quantum, and I am hoping to see each and every one of you. I'm not telling you go into physics. I had a student who realized that he could use the computer to give you a question. You remember when the pandemic, you had people, unfortunately, was waiting in lines to get food, and you had places where the foods were rotting because they didn't have the network? Can you imagine putting that information on a computer and not going one by one, but information goes out, and what comes to you is saying, this is the best route to get the food out to the people, the best way. That is what you're talking about, of how to help the resources that we have to make it better for human beings. All right, so I hope you liked my project. I gotta get back the filters. You can have the fish. Please, guys, the fish is not real, but if you wanted to make money off of somebody and give them a little fortune, I don't endorse it, but it's up to you if you want to do that, okay?
And if you want to do it to your friends.
And can I ask you, if you don't mind, collecting the filters for me?
You want to slide?
I mean, the slides, yeah, the slides of the filter.
You want those?
The fish is your gift.
Yeah, you want.
I want the slide, I want the filters, the slides back, okay? He's gonna come and pick it up for me. I'm gonna let my student be my helper.
Okay, let me,
And my last part is, let me finish. Thank you so much. This coming fall, I will be having a course at Morgan. You can do it virtually, with Gabby, with the Cubic by Cubic. We're gonna be doing coding. We're also going to be talking about some quantum experiments. So, and Friday, I'm going up to Canada to learn about modern physics and how to make the experiments even more so. So please, you know, we have a whole agenda that we like to share. Thank you. Did everybody get a chance to play with it? Great. Yeah. All right. So again, magina.murdoch@morgan.edu. Please feel free to email me, send me smoke signals. Not that I can read it, but let me know if you need to talk to me, okay?